Right shoulder.
Okay.
You're on.
Helps you
All right.
to
This-
write out a
Okay.
script.
This is my project. Very unique name, wireless steering wheel buttons for a car radio. I'm just going to write into the picture of what it does, or what the system is. You have, at the moment I only have 6 buttons. 6 buttons on the steering wheel is just volume, plus and minus, skip track, pause, and then answer call. It's a very fancy radio, it's Bluetooth. It seems to have cut off this part, but there's a steering wheel for a car. In the steering wheel, there's an Arduino with a wireless transmitter attached to the buttons that reads what buttons you press. Sends it wirelessly to another Arduino in the car, probably in the center console, hidden away. That reads the code from the wireless transmitter and sends it to the remote that goes to the radio in my car. I've cannibalized the remote that came with my radio, so it's pretty much as simple as plugging it right into the Arduino that I have to be able to get it to work. The block diagram is everything runs off the car battery. There's everything, the Arduinos can run off directly from 12 volts. The radio remote has to run off of between 3 and 3.5 volts. So I have a little mini 3-volt power supply for that, and everything else can run off, be powered by the Arduino. You've got the buttons, wireless transmitter, and Arduino. The analog switch, which is how I control the radio, it's got a special way of being controlled. You can't just send a digital signal to it. But after that, it communicates via RF to the radio. IR, infrared, LED. This is a schematic for the 2 boards that would go on the steering wheel. The buttons are separate. They're a separate board that goes up where you can press the buttons. They have a 5-volt input. They have a pull-up resistor, it goes to ground. Then they each have their own pin that goes to a digital pin on the Arduino. You push the button, it completes the circuit, it drives the digital pin on it. On the Arduino, you have the connector that comes from the board with the buttons, and they each have a digital pin, their 5-volt output. This is a representation of the wireless chip. I don't exactly have a very good explanation of the wireless chip besides the specifications that makes it important. But you have you have the data pins and all that. They're just what's on the chip that you can connect to the Arduino pins. Right here. This is what I have for the wireless chip. It's the voltage it can run off of, 1.9, 3.6 volts. So I have it connected to the 3.3 volt pin on the Arduino. It takes 14 milliamps at maximum is 14 milliamp current. Peter said it has a low power load, less than a microamp at one point if you use it right. And a maximum data speed of 2 megabits, which is pretty unique for something so cheap. Here you have the 2 pins that tell the slave transmitter receiver. You've got the clock, the data in and out pins, and then you got about 6 different spots to have the input voltage. I have 2 of these that I'm using, one on the steering wheel, one in the center console, Arduino Nano. It is the smallest Arduino you can get, as far as I'm aware. It can run off just about anything up to 20 volts, so it's good for the battery, to run off the car battery. It has a maximum current of 40 milliamps per pin, which I'm pretty sure includes a 3-volt pin, which is what I've been using. Which actually is something I might have to fix. I found out that the 3.3 volt pin only works when the Arduino is being powered by a USB. And now that I have when I run it off the 12 volt line, it won't work. So I'm going to have to extend my 3-volt power supply to just about everything now. There's built-in support for SPI communication, which is what the wireless chips use. And it has its very own low power mode if you really, really want that. Probably won't use it because it has to be active all the time. But yeah, the SPI communication, it has support for it, just doesn't natively have the software to run it. So I had to get my own library for it, and it was a very simple library. It has just the basic functions for SPI, just send a byte, receive a byte, activate the chip itself, set the channel, and set the CE and CSN pins, which were the send, receive mode. That was literally it. There's, I think, a few other commands, like there's a command to boot up the chip directly into send or receive mode, without having to mess with all the startup commands. But other than that, it was a very simple library. This is the schematic for what goes in the center console. You have the Arduino here, the transmitter there, the analog switch, which is, I think, pretty interesting. It's how it works is you have the remote attached here to this connector, and then each cable, but the remote basically works by shorting 2 pins in the remote together because it's got its own little surface mount chip on it. And when you short out 2 of the pins together, it sees it as a button press. So you have the specific pins that you connect with this switch. Each has N0 common. Okay, right into that. Hold on. That is the remote control. Yeah, it's a surface mount chip, so it's kind of hard for me to wire up every single pin on the chip. I found that on these rubber pads, kind of hard to see these rubber pads, but they're there. That's where the buttons were. You press the button, it would connect these pads together. Somewhere along these rubber pads, there was a little tiny circle of copper, and I was able to solder the ends of these wires to these little tiny pads of copper. And I was able to, run a ribbon cable out to the Arduino. And this is the analog switch that I was talking about. You've got these 8 pins at the top for power and commands and whatnot. You get the clock input. D in and D out is kind of interesting. You can daisy chain these together. So if you want to send the same command to multiple ones, you can repeat it. Then you've got ground minus reset. You can send a reset high signal at any point, and it'll just forget everything. So you can reset everything. And that's to activate the logic. So you can run this thing on anywhere from 2.7 volts up to 16 volts if you only have one single supply, like from 0 to 16 volts, or if you have a plus minus 8 volts supply, you can run that too, like on our breadboards. So if you want to activate a button, say I have one right here, you want to activate the volume plus button that's pin 10 and 14 on the radio, or on the remote. So you have the wires, or you have the pins for pin 14 running into, say, this one's pin 10, this one's pin 14. And then you tell the chip to close the switch, and it closes it, and then it'll activate the chip on the remote, and it'll turn on the infrared, send the code. And it allows up to 30 milliamps per switch set. Probably won't go that far. Hardly uses that much power. This is how the analog switch works. It has this CS pin, which is as long as it's low, it can receive data. And it will receive up to 8 bits at a time. It will only remember the last 8 bits. So if you send in 25 bits, it'll only remember the last 8. That'll be whatever you send that. So you have a clock signal, it can be whatever clock you want, but then it has to be consistent. As long as you have the data in pin high or low on the leading edge of the clock signal, it'll register that as high or low. And so we'll start with switch 0 and then 1, 2, 3 through 7. Actually, it's the other way around, my bad. From pin 7 to pin 0. So yeah, you go high, or you set the data high, and then you pulse the clock, and then you set however you want. And then data out will mimic that. This is the voltage regulator for the remote, which now I've realized I'm going to extend to the wireless transmitters as well. You have, it's pretty simple, it's an adjustable regulator. You have, the input can be up to 30 volts, it's pretty big. Output, at this point I only need 3.3 volts, so it's not too low. Your ground pin, or shutdown pin, which is very useful. You can attach this to a digital pin on the Arduino and you can turn the power supply on and off, which makes it just that much more efficient. You need a voltage divider from the output to the feedback and then to ground. The maximum value for R2 is 1.2 meg because of the current we need to go through the chip, so I decided to just be safe and cut that in half and use 500K for R1 since I knew R2 was going to be lower. And they gave me this, from the data sheet, gave me this equation for calculating V out with, if you use the V reference in IFV. And then you already know R1 and R2, so I just picked R1, 500K. And then I did a bit of math magic and mixed it around so I could get R2 out of it. And I found if with 500K ohms for R1 and R2 and an output of 3.3 volts, I would need 300K ohms for R2. And then just a filter capacitor on the output, and that's my whole power supply. That's the end of it. Any questions?
Can you show that, do you have a schematic of those voltage dividers and everything? There's nothing there.
That was right in here, yeah, it's right this section here. I've got from the feedback to the output, you have the divider here to ground, and then you have the 1 microfarad filter capacitor. Then you have the shutdown pin to a digital pin. Yeah.
Does that work?
Does that work? I haven't tested it yet. I haven't gotten it quite so far as I've made. That's why it's only schematic. I have I'm able to make these Arduinos communicate on a breadboard. I have the analog switch set up, and at the moment, I have it so I can, on the computer, hook it up and send a 1 to this with the serial input, and then I can turn on an LED on the analog switch. And the thing about the library for the wireless communication for the Arduino is that it's so simple, I can just add on to it. It's not exactly, it's not very tough. I can literally just say, I can send 1, 2, 3, 4, 5, 6, 7. I don't have to send anything even any more complicated than that. And it can just say, depending on which number it gets is which switch to turn on in the analog switch.
Have you recorded any waveforms for your analog switch? Because you're driving that serial input from Arduino to the analog switch.
Yep, I just have a, manually set up a clock in. I can quit out and show you some code for it if you want.
No, but probably on your website you want to do that. It may be a screenshot of the actual serial communications, but you're showing just what's in the data sheet, which is super generic. It might be more useful to have a screenshot of the actual pattern when you're pressing the up volume or something like that, so that you can see that it's somehow different each time. Each key press.
Yeah, I could do that. It'll just be a spike at different times along with that
Right,
clock,
right.
but still, yeah.
Yeah, and that would be, the value would be to show 2 or 3 different ones and
Even-
somehow associate them with the connections you've made to the home.
Even now, it's pretty quick, it's more or less instant how when the LED turns on, and even then my clock that I set up in my code is a 1 millisecond delay between clock cycles. So even then it's pretty speedy for that.
It'll be more than fast enough for you.
I had one quick question.
Sure.
So you said that Arduinos are 12 volt powered from the car.
It can be, yes.
Can be. Did you have a vision of like battery operation, or were you gonna make like a cigarette lighter adapter?
I was gonna make a cigarette adapter, yes, you can plug it into the car, have it work. The entire thing, I've done some quick and dirty math about it. If the wireless chips were to run full tilt 14 milliamps apiece, my remote uses a maximum of 40 milliamps. I know that because I've run it off the Arduino. That plus the minimal power you need for the analog switch, no more than 80 milliamps, less than a watt of power. So it's really not much at all.
Right. I just wondered if you get in your car, you turn it on, and the whole thing would just start up, or if you had to like.
Oh, in this case, my car does not turn on accessories until you start the car.
Yeah.
So that's just me though.
Right.
You might even on-off switch if it were a different car.
So you'll have something to show us next week?
Yeah, I can print off a little board with buttons that I don't have yet. I can set that up.
Okay. All right, thank you.